In this video, we talk about CPU and bus. So we know that the computer CPU is responsible for fetch, decode, and execute program instruction. Basically, we have two principal parts of the CPU are the data path and the control unit. The data path consists of an arithmetic logic unit and a storage unit. So basically, that's a register, and we have all the components are interconnected by a data bus, and that also connected to the main memory as well. So with the data bus, we can share and transmit information or data between the components. We also have the various components that perform a sequence operation according to signal provided by each control unit. We're gonna see how the control unit determine which device and perform which operation. Okay. So basically, the CPU main component include the register that hold the data can be readily accessed by the CPU. The register can be constructed by using the flip-flop that we discussed in the previous video. Um, for example, if we want to implement or construct a 32-bit register, we need a 32 D flip-flops. The next component that the arithmetic logic unit ALU carry out a logical and arithmetic operation as directed by the control unit. So basically, the control unit will determine which action to carry out according to value of a program counter register and also based on the status of the register. The system bus is used to share data with other system component. For example, the information sharing between the CPU and memory can be carried out by using the bus. So basically, the bus is just a set of the wires that simultaneously convey a single bit along each line. There are two types of buses commonly found in computer systems, that the point-to-point and multi-point buses. So here the example of point-to-point buses. So we can have the bus that connect between serial port to a modem. We also have the point-to-point bus that connect the ALU to the control unit. On the other hand, the multiple point bus that is shared by multiple devices. So for example, in the figure we have right here, the CPU, the memory, the disk control, and the monitor. So all of these devices sharing a single bus right here. So the bus right here we call multiple point buses, because the information can be transmitted from the CPU to the memory using the same bus. On the other hand, the information can be transmitted from the disk to the CPU using the same bus as well. In this case, the access to the bus is controlled through the protocol and which are built into the hardware. So the main components of the bus consist of a data line, control line, and a address line. The data line basically convey the bit from one device to another device, while the control line gonna determine the direction of the data flow. For example, data may be transferred from the CPU to the memory, or maybe from the memory to the CPU. And the control line also determine when each of the device can access to the bus. And the address line will determine the location of the source or the destination of the data. For example, when you write data from the CPU to the memory, the address line will determine which location in the memory the data will be written to. Here's an example of the system bus. We can see that the bus is shared by three main components: that's the CPU, the main memory, and the I/O subsystem. So the system bus here consists of three main components: the address line that basically indicates the location in the memory, for example, that the data should be either read or from or written to. The data line is the data bus which carry the data from one device to another device. The control lines indicate which device have permission to use the bus and for what purpose. For example, reading or writing from memory or from an input-output device. And the last component is the power line. So basically, power line provide the electrical power necessary in order for the bus to work. Typically, bus transaction includes sending an address for a read or write. For example, transferring data from memory to a register, a memory read, for example. In addition, the buses are used for I/O read and write from a peripheral devices. In the multiple point bus where we have multiple devices sharing the same bus, we basically just one of the device gonna be the master and other device gonna be a slave. So that's we call a master-slave configuration. We also can have more than one device can be the bus master as well. The concurrent bus master request must be arbitrated. So it means the system needs to ensure that the priority to certain master devices, and also at the same time make sure lower priority devices are not staffed. Just for category of the bus arbitration. Basically, the first type that's a daisy chain. So this permission are passed from the highest priority device to the lowest priority device. The second category of arbitration that the centralized parallel. So in this case, each device is directly connected to an arbitration circuit, and each of device have a request control line to the bus, and the centralized arbiter select who gets the bus. So you can see that in this approach, it can result in a bottleneck control issues. The third category that the distributed using self-detection. So in this case, the device can determine which device gonna get the bus among themselves in a distributed fashion. Okay. The last one using the distributed using collision detection. So in this case, multiple devices gonna try to use a bus, and if they detect a collision with other device, they're gonna backing up and try it again. So that's the some basic information about the CPU and bus.